Understand how to determine the hybridization of an atom. In organic molecules, the hybridization of carbon can be quickly determined by its steric number, the number of shared bonding regions/directions plus the number of lone pairs surrounding the atom. A steric number of 2 bonding directions, corresponds to sp hybridization, linear geometry. A steric number of 3 bonding directions, corresponds to sp to the power 2 hybridization, trigonal planar geometry. A steric number of 4 bonding directions, corresponds to sp to the power 3 hybridization, tetrahedral geometry. Note: under Vesper theory, double and triple bonds count as a single bonding region/direction. Analyze the carbon atoms before the reaction. In ethene, C2H4, examine either of the carbon atoms in the reactant. It is bonded to 3 other atoms, 2 hydrogen atoms via single covalent bonds, and 1 carbon atom via a double covalent bond. Carbon has 4 valence electrons and all are shared in bonds, meaning there are no lone pairs on the carbon atom. Steric number equals 3 bonding regions plus 0 lone pairs equals 3. Therefore, the hybridization of both carbon atoms before the reaction is sp to the power 2. Analyze the carbon atoms after the reaction. In the cyclic product, examine either of the carbon atoms in the product. The carbon-carbon double bond has been broken and replaced by a carbon-carbon single bond. Each carbon atom is now bonded to 4 separate atoms, 2 hydrogen atoms, single bonds, 1 carbon atom, single bond, and 1 oxygen atom, single bond. There are still no lone pairs on the carbon atom. Steric number equals 4 bonding regions plus 0 lone pairs equals 4. Therefore, the hybridization of both carbon atoms after the reaction is sp to the power 3. Select the matching option. The change in hybridization is before sp to the power 2, after sp to the power 3, which corresponds to option D. The correct answer is option D, before sp2, after sp3.